So the last section we're going to look at in Chapter 9 is 9.2. And this is on polar coordinates. We're not going to do 9.2 Part 2, which gets into the polar graphs on the calculator. I'll show you a couple graphs in polar, but we're not going to spend a lot of time learning how to graph in polar. Okay, that would have been Part 2. So up until now, even the kind of graphing we did yesterday was based on a rectangular coordinate system. So whenever you use function mode or parametric mode, you are using this kind of graph paper to draw your picture. Polar, not only is it a different coordinate system, but it uses a different kind of graph paper. Okay? So it's very different than what we're used to as far as the background. That's polar graph paper. So it's circular rather than rectangular. Okay? You like it?
No, I said it's gross.
Why?
I don't know. It's just.
It's fine.
I'm sure it is.
It's like when I go home and I just do this. I do polar. If I'm bored, you know. That's not weird.
That's fun. Just doing
No,
that.
I don't do that. Why would we use polar? Well, polar makes it very easy to draw certain things. Okay? What I want to do right now is I want to look at drawing a circle. I want to draw it on the calculator in 3 different ways. First, I'm going to do it as a function. Then I'm going to do it the way we learned yesterday. Then I'm going to do it in polar. I just want you to see the difference between all 3 ways. The picture is basically going to look the same, but it's how I'm generating the picture. All right, so let's start with a function. First of all, does a circle pass the vertical line test? No, then I can't even really draw a circle as a function. The only way I can kind of do it is cheat and do the top half and the bottom half separate. That's the best I can do. So I'm going to draw a circle. I'm going to let the radius be 3. I can pick any size, but let's do 3. To draw a circle with a radius of 3 as a function, you need to type in the square root of, I'm doing a radius of 3, so it's 9 minus x squared. That's the top half. It's the best I can do. Okay. And now I also have to do the bottom half, so I'll do a negative to reflect it. And I'll type in the same thing. And that's all we can do. It doesn't even really connect because the sides of the circle start to get vertical, and the calculator doesn't know what to do when it's in function mode and things start to get almost up and down. Let's take this, put that there. Okay, so that's what I typed in. This is the picture I got. Make that a little smaller. And that was as a function. All right. Now, let's draw a circle parametrically. Okay? At least parametrically, we know we can do it. We don't have to kind of fudge it and do the top half and the bottom half separate. We can make a real circle and it all connects. So if I go to parametric, does anyone remember what the equation is to draw a circle with a radius of 3 for the x one?
3 cosine t.
3 cosine t. And how about the y formula? 3 sine t. Okay, so there's my formula. So let's put that over here. You can already see it's a little bit simpler than what we had before. Right? We don't have to use square roots and square things and reflect things. We don't have to do any of that. And what does my parameter have to go from to get a full circle, but just one revolution? Yep.
0 to 2 pi.
If we're in radians, which we are, 0 to 2 pi. Okay. So it's exactly the same picture we just had, but this time it really is a circle. It's not two halves of different graphs stuck together. Okay, so a little bit better in the sense we can actually draw what we're trying to draw. So that was parametric. All right, now I'm going to show you the last one, and this is polar. Okay. So if I go to mode, change it to polar, to draw a circle with a radius of 3, yeah? Just type in a 3. That's it. Type in a 3, hit graph, and you're done. So out of the 3 different systems we just looked at, which one is the simplest to draw a circle? Polar. Yeah, polar is definitely the simplest. It's the same picture. It's just the formula that we use to generate it. Now, polar is really good for drawing things that are circular, spirals, anything like that. What do you think polar would be really complicated for? Straight lines, yeah. The best way to draw lines is to use functions. Y equals mx plus b. That's the easiest way to draw a line. Okay? To draw lines in polar, you need to use trig. So you have to understand like sines and cosines just to draw straight lines in polar. Okay, you can do it, but polar is not the way to draw straight lines. It's the way to draw circles. Right. So each type of graphing system has advantages and disadvantages depending on what you want to draw. But this is the one we're going to focus on today, which is polar. And we don't even really get into graphing on the calculator. All we're going to do is get into converting points. Like how do we convert single coordinates? That's all we're going to do. But I want to show you a couple graphs that are kind of neat in polar. Okay, so that one, you probably can't see that. Because that one's it's what we call a rose petal diagram. And that one happens to have 4 petals. Depending on what you change this number to, you can change the number of petals. Right, so that's one type of thing we can draw in polar pretty easily. Another thing we could do is something like 3 plus 3 cosine theta. I need to zoom out a little bit. Let's zoom out. And what does that shape kind of look like a little bit? But it's on its side. Like a heart? Yeah. Some people kind of see it. It's not as pointy as a heart, but it does kind of dip in a little bit like a heart. And that shape is called a cardioid. It's called a cardioid. Okay, so that's another shape. Another one we could do is, this one's pretty simple, a spiral. Okay, so and we can do that in parametric as well. I think we did yesterday. Those are just a few shapes that you can draw in polar. Okay, so petaled rose ones, the cardioids and spirals are 3 pretty basic ones. And then there's all kinds of other ones too. All right, so let's talk a little bit more about polar. Okay, so in polar, what we used to call the origin, they usually just call that the pole. Okay, you could still call it the origin, but in polar it's called the pole. The other thing in polar, there's only one axis. Okay, we don't have 2 axes. The only axis you have in polar is right there. And that's called the polar axis. There is no up and down axis that we use for anything in polar. What we want to look at now is how do you specify like that point in polar? It's not like a left and a right and then an up and a down. It doesn't quite work like that. In polar, Coordinates have two numbers, so that's similar to rectangular, but they're not x and y. It's an r and a theta. And those two labels are pretty accurate in describing what they are. What do you think the r is?
Radius.
It has to do with a radius, so that's how far out you move from the pole. And what do you think theta is?
This angle from the polar axis.
That's an angle from the polar axis, yep. It's an amount of rotation. So there's different cases we can have. We can have positive r, positive theta, negative r, positive theta. So what we want to do is look at what happens when we have positives and negatives. Which way do we go? Okay, so bar is the distance from the origin or the pole, and theta is an angle. Okay, so how do you graph a point? Well, the first number that you look at when we're graphing a coordinate in polar is r. That's the first number. We're going to look at theta after. Okay, you do r first. In terms of graphing, r is kind of like x. You can pretty much follow the same rules for that part. If r is a positive value, you're going to move from the pole to the right. How far to the right? Whatever r is. R could be a decimal or it could be an integer. It can be fractions. Those are all fine. If r is a negative value, then you're going to move from the pole to the left. That's not the final answer. That's just the starting point, just like when you do an xy coordinate. You do the x first, then you still have to do the y. Okay, so r is pretty much like x in terms of the behavior. The theta is totally different than y. So next we need to talk about that. Okay.
Why does it matter if you're moving left or right when it's a circle?
Because it's going to control your starting point. So if you had a point like 290, that means to go right 2, 1, 2, and then rotate 90 degrees, which is a quarter of the circle.
I see now.
If it's negative 2, then your starting point is left 2, and then you rotate 90 degrees. Okay, so the rotation amount is from after you do the r value. Okay, so you do the r first. From that point, you're going to rotate. Now we're rotating on a circle, so you don't describe rotation using up, down, left, and right. There's two directions for rotation. What are the two?
Clockwise and counterclockwise.
Right. So theta is either going to be a clockwise or a counterclockwise rotation. If the angle is greater than 0, you're going to rotate counterclockwise. It's the way we've always done it. If the angle is less than 0, we're going to rotate clockwise. Okay, so counterclockwise is this way. Clockwise is this way. So positive angles counterclockwise, negative angles clockwise. And again, that's after you do R. So you have to do step 1 first. Okay, so what we're going to look at is how do we graph some points? Then how do we change a point from the system we're working with now back to the coordinate system that we're used to? Okay. Okay, does everybody have the steps for R and for theta? Yeah.
Sorry, what do you mean in the parentheses from where we ended up?
So you do
Oh,
step
wait, so
1.
just like,
Yeah.
oh, okay, no, I get it.
You do step 1 first. That controls how far away from the origin you are. Then you rotate from there. All right, we've got to be pretty comfortable with everything. Degrees, radians, positives, negatives, decimals, any kind of numbers. Now, on polar graph paper, let me go back to the one that I had. Sometimes they break it up so you can do the angles a little easier. This one is broken up into 15s. So this is 0, 15, 30, 45, 60, 75, 90. You can get polar graph paper that breaks it up less, breaks it up more, goes by 10s. Just all depends on the graph paper. Okay, but this one goes by 15s. All right, so let's try this one, 345 degrees. Okay, on Edge Elastic, you will have a polar grid already drawn. You're going to have to click and put the point in the right spot. It doesn't have to be exact, but once we get the answer, I'll show you like other answers I would accept, and then I'll show you answers that would be totally wrong. All right, so start with R. What's R in this case? 3. And we're going to start out by going 3 units to the right. So kind of our temporary starting point. I'm going to erase that, but it's right there. So we go 3 units right. And then we're going to rotate how much?
45 degrees.
45 degrees. And then which way? Counterclockwise. So that's halfway through the quadrant. 45 degrees. All right, so I would accept anything right around there. If you had an answer anywhere in quadrants 2, 3, or 4, definitely wouldn't accept that. Okay. Even if you had an answer like way up here, that's a lot more than 45 degrees. That's close to 90. Okay, so it's just got to be somewhere in the middle. And again, my grid lines are going to be drawn for you on the graph, so you'll be able to get it a little easier. And that's it. That's how you graph 345 degrees. Any question on that? Okay. So let's try -2, 75 degrees. Okay, what's the radius in this case? 2, but the negative is there to tell you direction. We're not saying that the radius is like a negative length. That wouldn't make sense. The negative tells you to go which way? Tells you to go to the left. So we're going to go left 2. So we're going to start from there. And then we're going to rotate how many degrees which way?
70 degrees counterclockwise.
Counterclockwise. So that's going to put you pretty close to where the y-axis is. Okay, it definitely should be more than 45 because that's halfway. Okay, it should be 15 degrees before 90. And so any answer right around there I would accept. If you accidentally go on the wrong circle, then that I wouldn't accept either. Like if you did this down here, well that's -375, not -2. Any question on that one? All right, let's try this one. So 3, -60. So positive radius, negative angle. Okay. What's first step?
Move right 3.
Okay, so we're going to go right through. So we'll start from over here. And we're going to rotate how much and which way?
60 clockwise.
60 degrees clockwise. So 45 would be right in the middle. Just go a little bit past it. Any question on that one? All right, so we get a positive, negative. We get a negative, positive, positive, positive. We haven't done a negative, negative. That's this one. Okay, what's different about the angle this time?
Radians.
It's in radians. If you don't like it in radians, we can change it to degrees. So what is -3 pi over 2? -270. If you can do it without changing to degrees, that's fine. Okay, So what's our first step?
Left 4.
So we're going to start by going left 4. And then how many degrees are we going to rotate?
Clockwise, 270.
Clockwise, 270. So, well, if I rotate to the top, how much is that?
90.
And then halfway?
180.
So then I got to go 3/4. No, exactly 3/4. 270, exactly 3. So this is the way we did it. We went left, and we went around this way. Okay, I normally don't draw that arrow showing how we got there, but I want to this time because I'd like to know another coordinate that could get me to that spot besides -4, -270. Yep. So -4, 90. Okay. That one would be left 4. Rotate 90 degrees counterclockwise. Okay, that's another one. Another way. Yep.
+4, -90.
+4, -90. So 1, 2, 3, 4. Go that way. And one more. Okay, we got the negative, 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 positive, positive, negative. We don't have positive, positive.
So 4 is
4 and then what?
270.
270. So 1, 2, 3, 4. 270. So that should kind of indicate to us how many ways are there to get to a point in polar, at least that point. There's 4 ways to get to that point in polar. Now compare that to something like this. What's the coordinates for that point? 2, 1. What's another coordinate for that same point?
With whole numbers,
Yes,
there's no other.
there is no other. So when you're trying to get to a point in rectangular, there is only one way to describe the location. In polar, there's up to 4. I say up to 4 because sometimes there's only 3. If you have a point that lands here, there's only 3. There's only 3. Yeah.
So is 0 and 360 treated as the same? Because when you put in the calculator, you just put 3 and you do a full circle.
Yeah, 0 to 360 would be the same in terms of trig. Also, we don't really count going around more times as another way to get to the point. If you count that, then there's infinitely many. You could go right, go around 6 times and then stop. You could go right, go around 33 times and then stop. You're still going right and counterclockwise. So the 4 ways are right, clockwise, right counterclockwise, left clockwise, left counterclockwise. Those are the 4 basic ways. But again, if you are on the polar axis, there are only 3 ways. If you try it, you'll probably see why. There's only 3. All right, so let's try one with a 0. Okay, 0 pi. What's my radius that I'm going to move out this time? 0. But how much do I need to rotate? I need to rotate how much?
180.
Yeah, 180 or pi. So what do you think is going to happen?
No.
Yeah, so here's your point. Okay, at 0. But what you do is you take it and the green dots at the top and you got to rotate it to the bottom. Yeah. So the way I used to check for that when people did it on paper is I looked for what I call the spin factor. So when you put your pencil, your pen down, I looked to see that you spin it. And with a magnifying glass, I could see the grooves. You know what I mean? You could see like the lead, you could see the spin. Good. So 0 pi, it stays right at the origin. How about 2.50? Still has a 0. Is it going to be at the origin? No. Where's that going to be? Yes.
At 2.5, it's gonna stay on the line, right?
It's going to stay on the polar axis.
Yeah.
In this case, it's 2.5 units to the right, and then there's no rotation. What would be another coordinate to get to that spot besides 2.5, 0? Yeah?
2.5, 360.
Okay, 2.5, 360, so that's just adding a revolution. But how about besides adding a revolution? Yeah?
Negative 2.5, 180.
Yeah, negative 2.5, and you could go 180, negative 2.5, you could do negative 180, and then you can do the way we just did the first time. Those are the only 3 ways to get to that point. Any question on that one? Okay. We basically did that. Okay, so I already pointed that out to you. When you graph a point in polar, there is more than one way to get to the point. And the reason I show you that is because when you do calculations in polar, you might get a certain answer. But if it was a multiple choice question on the test, I might have a different answer listed. Okay, so maybe you get the answer in red, I list the answer in blue. You need to understand that they're the same thing.
Or you can have like a select all type of question, where it's like select all correct answers.
No, it'd only be, I wouldn't give you like I wouldn't call these all the same question. I wouldn't have this be like choice A, B, C, and D, because they're all the same. Okay, there'd only be one answer that's correct per problem, but it could be any of those. Okay. I would say most of the time I prefer positive when I'm writing an answer. All right, so let's see if we can convert the last 2 things. It's going to convert from the kind of coordinate I just talked to you about back to the ones that we were used to. When you have a coordinate in polar, what are the 2 things called that they give you?
Radius and theta.
And what are the radius and the theta. Yeah. Well, if you want to convert that to rectangular, what are the 2 things called in that system?
X and Y.
An x and a y. So what we need to do is get rid of the radius and the angle and turn it into an x and a y value. That's how you change polar to rectangular. Okay, so let's look at this. Let's say we had a point right there, and that's in polar. So there's going to be 2 things we know: the radius, and we're going to know the angle. Yep.
Is there a 3rd dimension in polar?
So you could do like spherical coordinates. Yeah, you can do that. I think that would probably be the closest thing. Yeah, but it's not really something that we study. Okay, so let's mark the 2 things you would know. Here's your radius. And here's your angle. Right there. We've got to convert that instead of how far out and an amount of rotation. We got to convert it to a right and an up. So what shape do you think we're going to make out of that?
Triangle.
Yep, we're going to make a triangle. And now that I've drawn that, what part of the triangle represents how far to the right I go? It's x, and what about, like, where is that on the triangle?
Bottom.
Yeah, it's the bottom, it's the base. So that's your base. And what part of the triangle represents the y? The height. So to convert from polar to rectangular, you're really finding the base and the height of a triangle. That's how you do it. All right. Let's start with x. What position is the side labeled x? That's adjacent. Let's label all of them. The side labeled y, opposite, and the side labeled r, hypotenuse. Okay. You're always going to use this, and you're always going to use this. If we want to figure out adjacent, which trig function has adjacent and hypotenuse in it?
Cosine.
Cosine. So the cosine, what's my angle?
Theta.
Theta, that's given to you in the problem. And what would be the fraction on the other side? X over r. And r will also be given to you. So the only thing we have to do is get, you know what, let me put that outside the box because that'll look a little better. And then when you get the x by itself, what would you put in there?
R cosine.
Bring the r to the other side. Yep. R cosine theta. Now we can go through the same thing for y. The only difference is it doesn't use cosine. It uses sine. Yep. So those are the two formulas to convert from polar to rectangular. This gives you the base of the triangle. The bottom one gives you the height. Okay. Any question on those two formulas? Let's try an example. So we've got the point 2, negative 200. Yeah, 2, negative 200. Okay, what's going to be my formula for the x value? Filling in the numbers that I have.
2 cosine negative 200.
2 cosine negative 200. All right, and what's the formula for y? 2 sine negative 200. Now, are we doing that in degrees or radians?
Degrees.
Degrees. Yep. So that's the first thing. Make sure you switch to degrees. Doesn't matter if you're in polar or parametric. We're not graphed. Okay. So we're gonna type in 2 cosine negative 200. 2 sine negative 200. So it's negative 1.88. And the y value was 0.68. All right, so write it as a coordinate. So that and the one that we started with are the exact same coordinate. Polar is the first one, rectangular is the second. All right. So what I did is I graphed on the right 2, negative 200. I went right 2, and then I rotated 200 degrees clockwise. Halfway around is 180. If I go to the first line, that's another 15. That's 195. And then I just went a little bit past it. Okay? So does everyone agree that that point is correctly graphed? All right. So what I'm going to do now is I'm going to change the background behind the point. As long as I use a background that's the same size paper, right? Meaning, as long as like my grid lines are right here on the rectangular paper that I'm about to use, about like that, what I can do is drop the new background behind it, and it should look like the point is almost 2 units left and a little bit more than half a unit up. Okay, but it's got to be the same size paper. So let's try it. Let's take this, put that there, right there, right there. All right. So does it look like it's almost 2 units over and a little bit more than half a unit up? Yeah. Isn't that amazing? That's the coolest thing you'll see today, right there.
I love that.
Okay, I'll do it again. I'll do it again for you. All right, so boom, there it is in polar, right? And then you change the background behind it. Boom. Negative 1.9, 0.7 roughly. That's pretty cool. Yeah, I know. I wait all year to do that.
Should we go then?
Now it's over. Okay. Let's look at this one. 3 5 pi over 6. Okay, what's going to be my formula for x for this one? 3
Cosine 5 pi over 6.
3 cosine 5 pi over 6. And what's my formula for y?
3 sine 5 pi over 6.
Now, what's 5 pi over 6? If you can think of what pi over 6 is, just times that by 5. How much?
75.
No, not 150. Pi over 6, that's 30. So 30 times 5, 150. 150 is a multiple of what number? Well, it's a multiple of a lot of numbers, but it's a multiple of what number that we talk about like in the unit circle? 15, another number? We talk about this a lot.
30.
30s and 45s. When you're dealing with an angle that has a 30 or a 45, and it's a multiple, they're going to write the answer as an exact. They're going to use a square root. This one I can't do, because 200 is not a multiple of 30 or 45. So that's all you can do for the top one. But the two numbers that you have to look out for when you do this are 0.707 and 0.866. Does anybody remember? They're both fractions. And they both have square roots. Does anyone remember what either one of those is with a square root in the unit circle? Well, what's one of the square roots that comes up in the unit circle?
Square root of 13.
Square root of what?
Square root of 2 over 3.
Square root of just what number?
2 over 3.
Square root of 2. Okay, so square root of 2 comes up.
That's what I said.
This one has something to do with square root of 2. But it's not square root of 2 over 3.
Square root of 2 over 2.
It is the square root of 2 over 2. So if we see a 0.707, we need to remember that that is exactly the square root of 2 over 2. 0.866, that's what's going to come up in this one. This one comes up with the 45s. This one comes up with the 30s. Does anybody remember the other square root that comes up?
2 over 2. 3 over 2. Square root of 3 over 2.
This one is the square root of 3 over 2. Yep. So we need to remember those two facts. Now let's do this problem. My advice is don't multiply by the 3 yet. That's going to confuse us. Let's just find the cosine of 5 pi over 6. Okay, let's do that first. What do I have to do on my calculator before I start it?
Change the radius.
Change it to radians. So cosine 5 pi over 6. In degrees, I just said change to radians. Okay, so cosine 5 pi over 6. That's negative 0.866. Okay, let's just write that down. So x is 3 times negative 0.866. So we're going to remember what that is in a second. And y, let's do the sine of 5 pi over 6. Well, that one's easy. 1/2. So that's not even approximate, that's exact. What's 3 times 1/2? All right, so we got that one. 1.5. Now, we don't want to do 3 times negative 0.866. We want to do 3 times what?
Square root of 3 over 2.
And just make sure we put a negative on it. That's the answer. 3 times root 3 over 2. That's how you'd see it written on the test. And then you can just write it as a coordinate. X, Y. As long as you remember these two decimals, those are the only two you would ever see. So any question on changing from polar to rectangular first? Okay, so what do you think the last thing is? Rectangular to polar. And what are the two trig functions we used here? Which one didn't we use? Tangent. That's going to be used to do the other way. All right. So now let's try rectangular to polar. In rectangular, what are the two pieces of information they give you?
X and Y.
Yeah, they give you an X and a Y. And in polar, you need a what? You need an R and a theta. So I drew a diagram. This time, the two things that you know, I'll circle. You would know the X, how far over, and you would know the Y. Let's see. That's how far up. If you know X and Y, how could you figure out the distance from the origin to the edge of the circle, which is your radius? Right, we need to use Pythagorean theorem to find the R. And then what side is X? Let me say it this way, what position is X? That's adjacent. What position is Y? And what trig function involves opposite and adjacent? Tangent. Now the tangent would be opposite over adjacent. But you don't want to have tangent. You want to get rid of the tangent, so this is by itself. So how do you get rid of the tangent on each side? Nope, not cotangent.
No, I said arctangent.
Arctangent, yeah. Arctangent or inverse tangent. Okay, I'll write that down nicely on the next page. But that's the idea where the formulas are going to come from. Inverse tangent and Pythagorean theorem. So the first thing we have to do, you don't really have to graph it, as long as you can figure out what coordinate your point is in. Because when you're finding your angle, it does matter the quadrant you're in. Okay? If you're in quadrants 1 or 4, you can do exactly what we just said. It's the arctangent of y over x. It's exactly what we wrote down right up here. Inverse tangent of opposite over adjacent, y over x. But the problem with inverse tangent is inverse tangent only works on this half of the circle. That's quadrants 1 and 4. Inverse tangent doesn't work by itself in quadrants 2 and 3. So to make it work in quadrants 2 or 3, we have to add 180. Okay, so that's why I say in step 1, figure out the quadrant your point is in. And if you're in 1 or 4, it's inverse tangent y over x. If the original point is in 2 or 3, you have to add 180 to that. Now, where else can you be besides quadrants 1, 2, 3, or 4?
On the left.
Yeah, you could be right on the axis. Pretend you were right there. I don't know what the y value is for that point. But what's the x value?
0.
The x value is 0. What happens if you try to plug in an x value of 0 into that fraction? Yeah, you'd be trying to divide by 0. So these formulas don't work if you're on an axis. If you're on an axis, you just have to memorize the answer. Okay? If you're straight up, what's that angle? That's 90. What about if you're on the left? 180, and then down? 270, and then the right would be 0 or 360. No. So that covers everywhere your angle could be. On an axis, that's the easiest case, because you don't have to do inverse tangent, anything like that. Okay, but if you're not on the axis, then you got to do the inverse tangent. Okay, so that gives you theta. And how did we say you're going to get the radius? What theorem? What is it? Yeah, I'm going to use the Pythagorean theorem. I just wrote it with the letters in our problem. R squared equals x squared plus y squared. All right, so we'll try 2 examples, just changing from rectangular to polar, and that'll be it. And I can leave that on. Right. So we need to figure out the r and the theta. It doesn't really matter which one you do first. They don't depend on each other. So let's do the theta first. Right 3, down 5. What quadrant is that in? It's not on an axis.
4.
It's in quadrant 4. What's the formula to find theta in quadrant 4?
Inverse tangent of y divided by x.
Inverse tangent. And what's y in this case? And what's x? 3. So I'll just type that in. I'm going to do it in degrees. Okay. Inverse tangent of -5/3. So that's fine, -59. Okay, we had negative angles. But what if I wanted it positive? What can you add to it?
180. 96.
360. Okay, if you add 360, you would make that angle positive. And that's what I showed you guys when we graphed polar points different ways. You can have negative angles or positive angles. I'm just going to leave it negative. -59.0. So there's your angle. Okay, and the radius. Okay, what's x in this case? 3. And when you square it, you get 9. What's y? And then when you square it, 25. And what's 9 plus 25? So the radius is the square root of 34. So your coordinate, r, comma, -59. Okay, and last one, 0, 6. Where's that? It's on an axis. That makes it very easy. Is it up, down, left, or right? Up. What's the angle when you go straight up? 90. And how far are we away from the origin if you're at the point 0, 6? That's your radius. 6. You don't have to do Pythagorean theorem. You can just count. You're 6. So that one's a little easier than the last one. Okay, so that's converting between polar and rectangular. And that's it for chapter 9. Okay, so homework is 1 through 14. 1 through 14.